Hello everyone, welcome to Headway Civil online study. In today's video, we'll be learning how to identify the zero force members in a truss. So there are two basic thumb rules to identify these zero force members in a truss. The first rule says that at a three-member joint, if two among the three members are collinear and there is no external load or support reaction acting at that joint, then the member that is non-collinear is a zero force member. So first let us look at this diagram. In this diagram, as you can see, there are 1, 2, 3 and 4. There are 4 joints present: joint A, joint B, joint O and joint C. The joints are connecting the members, that is AB. Here is one member AB. This is member AO, or we can say OA, second member. This is the third member, that is AC or CA. I am giving an arbitrary name, okay. It's BO or OB. This is OC or CO. So there are in total 5 members connected by 4 joints. While determining the zero force member, the first thing that we need to see, joint that is having no external load or support reaction. As you can see, joint B is having a support, that is pin support, or we can say hinge. Here it will have 2 support reactions, that is the vertical one, that is VB say, and there will be a horizontal one, say HB. Similarly, at joint C, since it's a roller support, it will have a vertical reaction, let it be VC. So the leftover joints which is not carrying any external load or reaction is A and O. So these two joints are not carrying any external load or reactions. As per the theorem, we need to look at a 3-member joint. See, it's been written. We need to look at a 3-member joint, out of which 2 among these 3 members has to be collinear. That means if we say somehow it has to be along a straight line. See, if we say this is O, this is B, or this is C, we can say BO and OC are collinear. So in this diagram you can see, if we consider this joint A, here AB, AO and AC, all the 3 members are non-collinear. So this rule is not valid for this joint, right? Let us look at this joint O. Here we can say BO and OC both are collinear. Theorem is saying that the other member that is non-collinear will be a zero force member. So the other member left is OA. So OA will be a zero force member. That means force in member AO, or we can say force in member OA, is equals to 0. Okay. Now let us look at the second theorem. The second theorem says that at a 2-member joint, if both the members are non-collinear and there are no external load or support reactions acting at that joint, then both the members are zero force member. Okay, here we need to look at a 2-member joint which is not carrying any external load or support reactions. Here there are total of 5 joints, out of which D is having a hinge support, or so it will have obviously support reactions in it. B is also carrying an external load P, so we will not look at B, C and D. The leftover joint which is not carrying any load or reaction is E joint and A joint, right? So we will need to look at 2-member joint. Since E is connecting 3 members, so we will not take this into consideration. We will be looking at a 2-member joint. Here you can see A is connecting 2 members, that is AE and AB. So it's a 2-member joint. And you can see both the members has to be non-collinear. And here AE and AB both are non-collinear. They are not lying along a same straight line. And there is also no external load at the joint A. Then both the members are zero force member. So here we can say force in member AE or EA and force in member AB or BA is equals to 0, right? Now let us look at some of the examples. So you can see in the first diagram, B is having a roller support, that is it will have a reaction in it. C is having a pin support, so it will have two reactions, so we will not consider B and C. And D is also carrying an external load P, so we will not consider the joint D as well. The leftover joint is joint E and joint A. So both the joints, as you can see, these are a two-membered joint, so the second theorem must be valid for it. Now let us check. In the second theorem, it has been said if at a two-membered joint both the members are non-collinear, then both will carry zero force, right? Here you can see ED and EC both are non-collinear members, then we can write that force in member ED and force in member EC will be 0. Now let us look at this joint A. Here also you are seeing that AD and AB both are non-collinear. So here also we can write as force in member AD and force in member AB will be equals to 0. In the second drawing, you are having 4 joints, out of which D is having support since pin, so it will have two reactions forces. We will also have two reactions forces, and there is already a load present here, so we will not be considering the joint A, D and C. The left joint is B, so we will be considering this joint B. Now the joint B is connecting 3 member forces, that is BD, BC and BA, right? So the first theorem must be valid for it. Now let's check whether it's valid or not, right? The first theorem tells that at a 3-membered joint, 2 member has to be collinear. As you can see, CB and BA both are collinear members, and the third one is a non-collinear member, that is BD is a non-collinear member. Then the third non-collinear member will be a zero force member. So we can say here the member BD will carry 0 force. In our third drawing also, similarly in the similar pattern you will be doing. As you can see, joint A, joint E is fixed, so it will definitely have reaction force. As you know that fixed support has 3 reaction forces, one horizontal, one vertical and one moment in it. So we will not be considering joint A and E, as well as we will not be considering this joint C because it is having an external load. So the leftover joint is joint B and joint D, out of which we can say joint B is connecting 3 members, right? Out of which BA and BC are collinear. So the third non-collinear will be a zero force member. So we can write over here BD will carry 0 force, that is the force in the member BD will be 0. We can reduce the drawing somehow like this. Say, since already BD is 0, we can draw it at somehow like this. So it's P and here it's A, D is there, right? This is E and this is A, right? We are not drawing BD because it's already 0 member. Here you can see D is also getting reduced into a 3-member joint, right? Out of which we can say ED and DC are collinear, these two are collinear. So the third one, that is AD, will be a non-collinear member, and as per theorem 1 it will be a zero force member. So we can write force in member DA or AD will be 0. I hope this portion is clear to you. If you have any problem, do comment in the below section. Thank you for watching. Do like, comment, subscribe and share my videos so that I can help you with more interesting civil engineering topics and portions. Thank you for listening.